Hello and welcome to the world of NDE 4.0. My name is Johannes Frana and today is a great day. Because today I have the honor to welcome all of you to my invited presentation at the SPIE Smart Structures and Nondestructive Evaluation 2021 Digital Forum. Now, but before we really get into my presentation, a big thank you to all of you for watching this video, and a big thank you especially to Norbert, because Norbert was the one who invited me to this presentation. It was Norbert who invited me to become the editor for NDE 4.0 for the Journal of Nondestructive Evaluation. It was Norbert who invited me to become part of the editorial board of the Handbook of NDE 4.0. And it was Norbert who, back in 2016 or 17, Norbert created the term NDE 4.0. So Norbert, thanks a lot. But now, let's get into the topic of this presentation. So, we will be talking about NDT and sensors becoming natural allies by digital transformation, by Industry 4.0, and by the Internet of Things. Now, here I'm saying NDT and sensors, but for me, both of them are actually one. Both of them for me are NDE, non-destructive evaluation. Whether we perform something like a testing, like some ultrasonic testing on a component, or whether we put some sensors on some equipment, both is non-destructive and both is material evaluation. So for me, those two are one right from the start. But I think it will change now with the digital transformation, with the fourth revolution, that those two are even growing closer. Now, Rippy already talked about the four industrial revolutions and also about the four NDE revolutions. And I don't want to say a lot about those topics, and if you want really to get into details about those four, I've put some links on the bottom of the screen. But what it really comes down to is industry. Before the first revolution, we had handcraft and we became to simple mechanization, some changes due to all the electricity we got, the digital revolution, and finally the interconnected cyber-physical. Similarly on NDE side, starting with perception, with procedures and simple tools. Now, that is perhaps the biggest one. What I describe here as analog is really that we made information accessible to us, which we as humans cannot see with our senses. Something like hear ultrasonics, or to see X-ray, or to see infrared. And then came digital. Digital really made it all that information more accessible. It allowed to do imaging, and then getting into the interconnected cyber-physical. And this evolution of industry, of NDE, of sensors, we can see it's growing together. It's getting more and more to one central point, to the interconnected cyber-physical. And even if you think about our household goods, like an Amazon Alexa or how they are called, yeah, that is part of the same thing. So it's kind of all our goods we have are growing together. And perhaps the question is coming up, why are we going this direction? Now, it's actually pretty simple if we look onto Abraham Maslow's hierarchy of needs. We started back in those days before the first revolution. Actually, for most people, life wasn't really that good. They had to be lucky to have one set of clothes. And then with the first revolution, actually, it became normal to afford clothes, to afford food. And therefore, yeah, they moved up one step of that hierarchy. Then came the second step, or the second revolution, and people got into love and belonging, into friendship, family, intimacy. Then we came to the third revolution, and that's the one we all know out of our hearts, because we we lived in, we grew up in that third revolution. And this is really about, oh, I have the bigger car. This is esteem, this is self-esteem, this is confidence achievement. Now we're getting to the fourth revolution. And the fourth revolution in space, it's really about, that the human is doing what the human is really good at. Solving problem, being spontaneous, being creative. And now if we look a little bit into those four revolutions or into the first three, we see that each of them took about 50 years from start to the end. With the fourth revolution, that one started somewhere around 2010. So it's now about 10 years into that revolution. And people are already discussing Industry 5.0 and stuff like that. I don't like that. And because I think most of the ideas they are putting into Industry 5.0 or what they see could be Industry 5.0 will eventually be seen as a part of Industry 4.0. We still have 40 years to go. And a lot of that point which are currently discussed under the name Industry 5.0, I think they will just belong to the fourth revolution. And for me, the fourth revolution will be the last one, because now we kind of reached self-actualization. And that's really where we as humans want to be. Now, a little bit different view on that whole topic of the cyber-physical really brings a view on the word digital, or on the verbs connected to that word. Digitization is just the conversion from some analog information into some digital information. So taking a sheet of paper, scanning it, and making a PDF out of it. Or taking some music, making an MP3 out of it, and storing it on your computer. So this is the heart of the third revolution. Now we're getting into digitalization. Now digitalization is a whole different story. Now we are making processes digital. We are creating workflows, digital workflows, all for a certain purpose, to make our lives in the industry easier, or not only in the industry. So this is now we are on the way to the third revolution. And now we are getting to digital transformation. Now, where digitization and digitalization, that is really something you can buy kind of as a product from some companies, or you can do within your own company. Digital transformation is something where we need collaboration. This is where perhaps we want to combine an industrial Internet of Things with a digital twin, with an AI, with a lot of sensors, with a lot of NDE. So it is all those companies which have to work together to actually make this happen. Now, and the heart of the digital transformation, this is really the cyber-physical loop. And the cyber-physical loop starts with, all your assets you have in your production, your actual production facility, which we see right down here, some of your financial data, a lot of sensors you have installed, and perhaps your design data. And you take all of that data and you combine all of that data in the Industrial Internet of Things IoT. And you take all of that data, you convert it into information, you put it into the digital twin, you have a lot of data processing in your digital twin, like an AI or a quantum computer. You somehow visualize that data, or you create automatically some knowledge out of all that data and your data processing. And that finally, creates some action back in real life. And that closes our cyber-physical loop. And the digital transformation is to make all of those steps possible, to integrate all of this for the greater good of our customer. Now, we talked already a little bit about the two phases of NDE. On the one side, the classical NDE with the surface inspection methods, with the volumetric inspection methods, and last but not least, with all the reconstruction technologies we currently have. And on the other side, or on the other face, is then all the sensors, all those different types of sensors, sensor arrays, and also reconstructions for those sensors. And those two, for me, they are both non-destructive evaluation. But people see them a little bit different. And you can group them kind of, especially if you think about, on the one side, information content, and on the other side, the system cost, the system complexity. Or if we take the inverse, that will also lead to the inspection rate. If we think about the classical NDE, it's a very complex system. We can only do those inspections, let's say once a year or once every 10 years. But the information content we get, especially if we think about a computed tomography, is really high. The classical NDE will be somewhere up here. Whereas NDE sensors, structural health monitoring, condition monitoring, we can achieve really high inspection rates. But also the information content is perhaps a little bit lower. And so for me, those two, they are not sitting on the same spot. They have different applications. But we have to really work together. Now, if we think about how people see those two technologies, if we think about sensors, they are installed mainly to monitor assets. And this is why they are initially in connection with Industry 4.0. Classical NDE, it's longer around and it's installed to assure the quality of the assets. Primary customer for sensors is engineering. But a classical NDE, that's quality assurance. Primary use for the sensors is a longer life, to learn more about our assets, to all those feedback loops. Classical NDT, identifying rejectable defects. And therefore, the primary view of customers on sensors is, oh, this is a value center. But in classical NDE, it's a cost center. And for me, there is no reason for distinguishing them in this way. Because for me, both phases of NDE provide information about the internal structure of the asset. Both are valuable data sources, and both should be used for Industry 4.0. Okay. So out of this picture, out of this cyber-physical loop, which we currently find in some places, we have to get to a holistic cyber-physical loop, which includes sensors and NDE, which includes both phases of NDE, because the data we acquire with NDE and the data we acquire with sensors, it gives us more. It gives us a really detailed view into the components. But how do we do it? We need to give our data some structure. We have to make our data machine readable. We have to convert the data to information. But how do we do that? We're doing it with semantic interoperability. Now, I guess most of you, if you read that number, you immediately know what will be coming. But if I enter the number 42 into my computer, he doesn't have any clue what I want to tell him. He doesn't know is that the length of the truck, the gain of the UT instrument, or the value of some sensor. But if I give him all the parameters which describe that, for example, it is the gain of a UT instrument and of the UT instrument from a certain manufacturer with at a certain day and so on, with a certain component, then the computer can actually take that data and process that data automatically. And then if he has all of that, he will know that this is actually the answer to the ultimate question of life, the universe, and everything, at least according to Douglas Adams and his book, Hitchhiker's Guide to the Galaxy. Now, we have all of the data acquired. We have converted the data to information with semantic interoperability. Now we want to use it in a digital twin. What's a digital twin? Now you can create a digital twin also of a person, in that case about myself. And if I take my financial data, my medical data, my operational data, or something like my size and weight, or my friends, then I can take that data, put it into some data processing, create knowledge out of that, and then perhaps know how to better sell that person a certain item. And that is what those three know. That's why they are collecting all of that data we currently see that they are collecting. And if I think about our governments or our health insurance companies, they are doing the same. They want to gain more knowledge about us so that they can better sell us something else. Now we can do the same for our inspection system or for our sensor system. We can do it for the complete production line. We can actually also do it for the complete enterprise if you want. We can create a digital twin for an enterprise. Then we can have a digital twin for the inspection equipment, for the individual sensor, for the software we're using, and for the inspector. So this is kind of a nesting structure. We have the enterprise all the way on top, and then we have this nesting structure going more and more in detail. And that is kind of equipment-related digital twin, so something which is producing or inspecting something. On the other side, we have product-related digital twins. Every product starts at some point with an initial idea. Then we come to some design, we produce raw material, we produce individual components, we assemble those components, we put them into operation, and finally we get to some end of life, some recycling, reuse, or whatever. So we have already seen this nesting structure from the enterprise all the way down here to our inspector. And we have also seen this thread, this lifetime of our component or this lifetime of our product, starting with the idea going to the end of life. This vertical axis, I already called it nesting. The horizontal, that's the digital thread. And we start with a type for a digital or a type of a component. And then once we start with the production, we are producing an instance. And now we don't only have one instance, we have dozens of instances. So we can actually create an aggregate of all of those instances. So this is kind of a little bit about all the variety of all the digital twins we have and how they are all connected. And you can see already, yeah, we have that nesting here for our inspection equipment, but you can do the same nesting actually also for a design phase or for an operation phase. So kind of we are getting into a digital weave, but that's a different story. Now, if we look a little bit deeper into the digital twin, we already said we have to start with some information. We continue with data processing. We come to some visualization to gain knowledge and some actions. Information, that's data coming out of databases, out of the cloud, out of the IoT. And once we combine it with semantic interoperability, we are getting information. What we also need, we need some reliability information for every data we want to use. Because even if I want to use some financial data, I need to know how reliable that financial data is. Then we are putting all that data into some kind of data processing, can be an AI, can be a quantum computer, for trending, for predictive maintenance, for probabilistic lifing, and so on and so on. You know all those different methods for our big data processing. Then we are using some visualization, like a dashboard or an AR, to actually create knowledge. And finally, we are creating some action. And best is if we can do all of that in real time. And this is kind of this cyber-physical loop, this holistic cyber-physical loop, from IoT to the digital twin, to knowledge, to action. And this kind of connects all of those emerging technologies we are currently discussing. If we think about cyber-physical loops, or if we think about our life of a product, we start with an initial idea, we come to design, we produce raw material, we produce individual components, we do a production inspection, an inspection of the individual component. So that is classical NDE. We are getting to assembly. In the assembly, yeah, we will do some structural health monitoring, some condition monitoring. Same during operation. We're getting into some service inspections. And finally, we're going to the end of life. The first couple of them are really that is what happens at the asset OEMs and the supply chain. Then we are coming to owner operators and finally to the end of life. Now, if we think about classical NDE, yeah, we can use the data out of our production inspection to enhance our inspections. That's a cyber-physical loop. Same we can do with the service inspections. But we can also use, for example, the data of our production inspections to enhance the production of our component or our raw material, our design, our idea. The same for service inspection. And now if you think about if we want to reuse a component or something like that in the end of life, we have to do a couple of other inspections. So again, here we have some other cyber-physical loops. Now, if we think about the other phase of NDE, all the sensors we have in structural health monitoring and condition monitoring, yeah, again, we have all those cyber-physical loops, and we need to use all of them to really come to a holistic approach, to all those methods. So for me, structural health monitoring, condition monitoring, sensors, classical NDE, they are all natural allies of the fourth revolution. We are kind of the gas which makes all of the fourth revolution go because we provide the data. But what we need for that, we need data transparency. And that is number one, open interfaces and open data formats, semantic interoperability, data security, and data sovereignty. And because I think that this is so important, or we thought that this is so important, the German Society for Non-Destructive Testing actually created a memorandum of understanding. And if you're really interested in it, just send me an email, I will send it to you, and perhaps you can also sign on it. Moreover, we are also offering trainings and consulting on NDE 4.0 because in our view, we can do NDE 4.0 just by themselves. We have this huge thing, this our cyber-physical loops. And this is where you need to have a little bit help to not run in the wrong direction, to really get it focused and do what is best for your business. This is also why we created a YouTube channel on NDE 4.0, where we get into all of those things I spoke about in more detail, where we have a lot of guests speaking about all of those different subjects. There are a lot of activities at the national societies. First one was the German Society, then we started with the American Society. By now we also have some activities in the EF NDT and IC NDT, so in the international commune, and also all the other national societies. We have worked on special issues, materials evaluation, RNDE, and Journal of NDE. And last but definitely not least, we will have the first international conference on NDE 4.0 pretty soon. We will start April 14th for 4 consecutive, or not consecutive, for 4 days. In between we have a weekend. It will be 2 runs to accommodate all the time zones. We have a lot of different presentations. I think it is more than 18. You can actually view the program currently online. We have special sessions for all the national societies. We have 4 different panel discussions. And then we will repeat the same 2022, but not virtually, but this time face-to-face in Munich, in Germany. But thanks a lot for paying attention. Thanks a lot for watching this video, for watching my presentation. So thank you. See you soon. Thanks and bye.